Hi everyone. In this video, I am going to explain about the basic principles of pass transistor circuits. So, what is the purpose of pass transistor? Why we should study about this pass transistor? Pass transistor is nothing but simply a NMOS or PMOS transistor which appears in front of any logic circuit. Suppose we have a logic circuit here. Okay, logic circuit may be a simpler one or a complex one. In front of this logic circuit, we are having some other circuit where one transistor may be appeared like this. Okay, so we have some input over here. That input connected to this logic circuit through a transistor or through any other circuit. Okay, here we have some clock signal. This is the input. Clock signal is nothing but a control input for this transistor. Based on this clock signal, on-off conditions will be there and the transistor becomes on and off when clock is equal to 1 and 0 simultaneously, and the input is applied to this logic circuit. Now, the question is, when the clock is high, transistor is in on state, okay, the input will be transferred to the output. This is what the assumption is. Okay, now whether this complete input will be appeared or not, whether this complete input is appeared or not at the input of this logic circuit. Okay, at the input of logic circuit, we know very well some parasitic capacitance effect is there. Parasitic capacitance is nothing but a virtual capacitance, which is nothing but an input capacitance that is appeared from gate terminal to the ground. Gate terminal to the ground. Gate is nothing but at the input. So from here to ground, we are having some capacitance effect at the input of this logic circuit because of the high input impedance. We know very well CMOS circuits are having high input impedance. So now, what is the status? What is the status when input is high? What type of voltage that is appeared at this particular point? Okay, we can call it as V out. Okay, so when input is equal to high, what is the output? When clock is equal to 1. When input is equal to 0, what is the output? When clock is equal to 1. Why we are studying about only when clock is equal to 1? Because the input will be transferred to the output if and only if the clock is high. When clock is 0, low, then transistor is in off state and there is no connection between input and output. Okay, so in order to understand such characteristics, we should study about this particular pass transistor characteristics. That is the main importance to study about the pass transistor logic. Okay, before going into the capacitance actions, let me first describe about the pass transistor on-off conditions. So, pass transistor. Pass transistor can be made up of either PMOS or NMOS. It may be either PMOS or NMOS. So simply it is a transistor which is connected between input something like A and output Y. And here we have a control input. Here we have control input. This is of NMOS type. This is of NMOS type. So what is the output Y when transistor is in on state? Do we expect complete A as output? So for NMOS transistor, NMOS pass transistor I am studying. So NMOS Y is equal to A minus VT. Y is equal to A minus VTN, where VTN is the threshold voltage of the pass transistor when the transistor is in on state. Okay, so Y is equal to A minus VTN when control signal, when control input is 1. It is equal to simply 0 or open circuited when control input is equal to 0. You can say open circuit. Y is equal to open circuit when control input is equal to 0. Okay, so when control input is equal to 1, the transistor is in on state. This on transistor makes a voltage drop across this, which is nothing but threshold voltage of this MOS transistor. Then Y is equal to A input voltage minus this drop is equal to output. Okay, this is what the main condition we have to understand. When pass transistor is in on state, definitely there is a voltage drop across this. Suppose if it is a PMOS pass transistor, PMOS pass transistor. So PMOS pass transistor also acting like NMOS pass transistor, but here we are having control input, and this is A, this is Y. Now Y is equal to A plus VTP. Here the threshold voltage for the pass transistor is negative. So A minus of minus VTP is equal to A plus VTP when control input is equal to 1, and control input equal to 0. Sorry, this will act per reverse order, because if it is a PMOS transistor and it is equal to open circuit when control input is 1. When control input is 1, what happens? The transistor is open circuited. PMOS on off conditions are different for NMOS on off conditions. Okay, so we have to understand one thing. When A is equal to when input is equal to control input is equal to 0, when control input equal to 0, then Y is equal to A plus VTP. Okay, so now with this output voltage, now what we have studied here up to here, we have studied up to here. Okay, now at this point we are having a capacitor at the input of the logic circuit. Okay, this particular voltage, now let us continue the operation with the operation of NMOS pass transistor with or at the input of logic circuit. Okay, now we are having this NMOS transistor, whatever we have studied so far, and this we are taking the control signal, now we are replacing with a clock signal, and this is what we have seen, which is nothing but Y is equal to input A minus VTN. Okay, this is the input. Previously we have taken A, here it is now input, and here we have some input capacitance. This is the logic circuit. Okay, whatever will be the logic circuit, we don't bother about the circuit, but what is the input appear for the logic circuit is important. Okay, this is the capacitance, and what is the amount appeared at this particular capacitance voltage. So VC equal to how much? That is our target, because VC is the voltage that is appeared at the logic circuit input. Even if we think input we are giving like this one, but we are not expecting this input at the input of the logic circuit, because the input has to pass through the pass transistor and the capacitance. Okay, now what is the operation? See, for logic one, when input is equal to logic high, now the first case is when input is equal to logic high. So when input is equal to logic high, this one passes through this pass transistor, and the one output is Y is equal to 1 minus VTP. Okay, otherwise we can take, so input is equal to VDD, that is input is equal to VDD, and Y is equal to, Y is nothing but voltage appeared at the output of pass transistor. Voltage appeared at the output of pass transistor. So it is VDD minus VTP, VTM, VDD minus VTM. Okay, now the capacitor has to charge up to this voltage, because this is the amount of voltage appeared VDD minus VTN and VTN, and the capacitor has to charge up to this voltage. Capacitor has to charge up to this voltage. So what happens? Capacitor slowly charges. So we can draw a voltage curve. This is the actual input. We are expecting VDD, and this is the practical input appeared across the capacitor VDD minus VTN, so that the capacitor slowly charges and reaches the maximum potential after certain amount of time. Okay, so this is the VC, voltage across the capacitor. Hope you understand how the capacitor charges when the input appeared across it. Okay, that means after some amount of time, the output will be reached to the uh, maximum value, nothing but VDD minus VTN. Okay, now when input is logic 0, when input is equal to logic 0, when input equal to logic 0, what happens? Input is equal to 0, nothing but V, what is this? Input equal to logic 0 means Y is equal to 0 minus VTN is equal to minus VTN. Now the voltage has to be discharged, open circuited, or we can say the transistor is simply open circuited, or there is no connection between the input and capacitor. So the capacitor has now a discharging path through the other two terminals of the transistor, through the drain and gate terminals of the transistor. So capacitor has to discharge. Capacitor has to discharge. Previously it has charged up to VDD minus VTN. Now it is discharging this voltage. So it is VDD and this is VDD minus VTN. Now the capacitor discharges till 0. So this is voltage across capacitor. Okay, so even if the input conditions are being changed suddenly from 0 to 1 and 1 to 0, the output or the logic circuit input appeared here because of the existence of capacitance, that will not show a sudden change. Okay, that is the effect of pass transistor followed by a capacitor at the input of logic circuit. Okay, all these are very important when we are going for the digital logic circuit design and implementation. Okay, we should consider about the characteristics of pass transistor and the internal parasitic effect when we are going for the implementations. Okay, thank you.